So in this example, which is sample problem 3 by 2, and this is taken from the GL Merriam book and is one of the uh, question in your tutorial sheet. So a small inspection car with a mass of 200 kilogram runs along a fixed overhead cable and is controlled by the attached cable at A. This is the inspection car, and this is the which is run along this overhead cable, and is controlled by the attached cable at A, which is this is the we are controlling it from here. So determine the acceleration of the car when the potential when the control cable is horizontal and under tension of this one 2.4 kilonewton. Also find the total force P exerted by the supporting cable on the wheel. Okay, so in this case, what we can write is the T, which is given is uh, 2400 Newton. So we will multiply this 2.4 kilonewton by 1000 because it's in kilonewtons. We will change this to Newton. And again, mass is given of the of this inspection car, which is 200 kilogram. And what you need to calculate, A, which is unknown, and you also need to calculate the P in this case, which uh, is the total force exerted by the supporting cable on the wheel. So now to solve this problem, the first thing that we need to do is that uh, we need to draw the free body diagram before trying to solve this question. So as you can see that this is the cable here, the direction of the cable, and in this case, as we discussed earlier, that we will try to draw a rough sort of representation of this um, cable here. But obviously, in this case, we want to calculate the acceleration of the inspection car. So we will draw the free body diagram of the inspection car. So in this case, this is the inspection car here, and now we will need to apply all the forces on it. So the first force, which is the this T here. So T is in this direction here. So this is the T, which is given 2400 Newton here. And you also have to calculate the weight. So in this case, the weight will be in the vertical direction. So this will be the weight of uh, this inspection car, and you can calculate the weight by using this mg. So m is given, which is 200, and g, which is 9.81. So this will give you this weight, which is 1962 Newton. Okay, and we know the weight now, and we know that the P is perpendicular to the cable, which is the force of the cable on the inspection car, and we will assume that the body is accelerating in the upward direction. So ax, and the coordinate system that we will assume is that x is in this direction here, and then y is in this direction here. Okay, so this is our free body diagram. Now, in addition to these forces and angles, you are also given this small triangle here, and which is 5 by 12. So this means that from this triangle you can calculate the angle of this cable here. So if you just draw this here, so you can also write it this way. This means that this is the slope of this cable here. So this is pi by 12. So from here you can calculate this angle here. So this angle will be theta will become equal to tangent inverse pi by 12. So which will become 22.62 degrees. You manage to calculate this angle here, which is obviously this angle here. This is our theta here. Okay, so now we need to calculate ax and this p here. Now for this case, we will be using the Newton second law. So what we will write, that summation of all the forces in x direction equal to max. Okay, and this acceleration is in x direction, or this is the component of acceleration in x direction. So even you don't need to write the arrow on the top of it. So in this case, now we need to collect all the forces in the x direction, and we know m, and then it will give you the ax. So now we have these three forces. One is p, one is t, and one is w. But obviously p is in the y direction, so it's have nothing to do with the x-axis. But we have w, which is neither in x direction nor in y direction. It's somewhere in the middle. Similarly, t is not in the x direction, not in the y direction. It's somewhere in the middle. So we will need to find out the component of w and t in the x and y direction. So if we choose if we split this, we can say that this is our tx and this is our ty. So this tx is the component of this t in the x direction, because x in this case is that we are choosing that x is in this direction, and y is in this direction here. We can also choose x and y in the horizontal and vertical direction, but then you will have acceleration in x and y direction, so it will complicate the problem. So it's always good idea to choose the x direction in the direction of the acceleration to make it simpler. Now, as you know that this angle is theta here, and if you see this angle is the same as this angle here, so this is also our theta angle. So then from t we can calculate tx and ty. So this means that tx and ty are known now. Similarly, we also need to split the w in two components in x and y direction. So again, we will need to write these two components. This will become w in the y direction and w in the x direction. Okay, now in this case, this angle is theta here. So now you may be aware of this rule, that if you have two lines, so for example, if we have these two lines, and if the angle between these two lines is theta, so if you write another set of two lines, so if one is perpendicular to this one, and another one is perpendicular to this one, so this means that if this angle is theta, so this angle is automatically theta. If these two lines are perpendicular to the original lines, so in this case, as you can see from the w, that this angle was theta, and this line is perpendicular to this line here, so this line here, and similarly this is perpendicular to this line here. This means that this angle is automatically theta here. So now if we know w, which is the weight, which is we already know, and so then we can calculate wx and wy. Okay, so now if we use this this equation here, so summation of all the forces in x direction, now we know the forces. And again, we are it's always good idea to write this thing, that all the forces will be positive in the positive x direction, and obviously the acceleration is in the positive x direction is positive. So then we can say that this tx, which is in the positive x direction, will be positive. So tx And if you look at this force here, the Wx, which is also in x direction, but it is in the negative x direction, which is opposite to this x. So this will become minus Wx. And this will become equal to MAX. So we have these only two forces in the x direction here. So now we can put the values of Tx, omega x, Wx, and then M, and then we can calculate Ax from here. So we know that this Tx is 2400, and we know that it's cos of theta, and we know theta, which is 22.62, and then minus Wx, which is 1962, and sine of 22.62 equal to M, which is 200 Ax. So from here, then we can calculate Ax, which is the only unknown in this equation here. So Ax will become equal to 7.3 meter per second square. So we managed to calculate the first unknown, which is this unknown here, A, of this inspection car along the cable. And because our x direction was along the cable, so this Ax is automatically equal to A. Now in part B, we need to calculate the P here. So for this, we will use the equation summation of all the forces in y direction equal to MA y. Because in this case, y is perpendicular to the cable and the inspection car is only moving in this direction here. So there's no motion in the y direction, which is perpendicular to the y. So obviously this right hand side is equal to 0 here. So this means that summation of all the forces in y direction equal to 0. Now we can use this equation to calculate P here. This means that we will need to collect all the forces in y direction now. So if you again, we will assume that this is our positive y direction, and we will take all the forces in positive y direction is positive. The first force is P here, which is in the positive y direction. The second force is uh, this force here, which is minus Wy, which is in the negative y direction, in the downward direction here. And again, this Ty is again in the downward direction. So this will also be negative, minus Ty equal to 0. So from here, you can calculate that P is equal to Wy plus Ty. If you just put the values of Wy, so Wy in this case is, again, you know the W, which is 1962 cos of angle, which is 22.62 here. And then you can also say Ty. So Ty is again opposite angle, opposite side. So opposite to this angle theta. So which will become Ty, which is 2400 sine of 22.62. So from here, then you can calculate the P, which will become 2734 Newton, or you can say that it will become 2.73 kilonewton.